Let's talk about sound waves. Sound waves can propagate in solids, liquids, and gases. The speed of propagation depends on the medium, and so the fastest speed is in solids and the slowest is in gases. Let's talk about the mechanism of propagation of sound waves. Sound waves are longitudinal waves, which means that the oscillations of the particles of the medium are parallel to the direction of propagation. If we look at some particles in the medium, then they will oscillate back and forth parallel to the direction of the propagation of the sound wave. So once the particles are going to the right, after that they will be going to the left. And the direction of propagation is to the right. Let's look more specifically at propagation of sound in gases. So let's look at a tuning fork that creates sound waves in air. The tuning fork is oriented so that the vibrations of the two prongs are left and right. So therefore the sound waves will propagate left and right in air. And here we are only looking at the waves created by the right prong. So let's sketch and see how the actual generation of the sound waves happens. So here is the prong, and it oscillates left to right, and it's going to move the air molecules by mechanically colliding with them, setting them in motion to the right. These molecules will collide with the molecules closest to them, and that will set those molecules in motion to the right as well. Those molecules in turn will collide with the molecules next to them, which will set those new molecules in motion to the right, and so on and so forth. However, if only that type of process is happening, all molecules going to the right, that would imply that around the tuning fork, at some point, there will be no air molecules left, and then that means that there is vacuum, which is not the case. There is still air around the tuning fork. So that means that the molecules that are in contact with the tuning fork are not going away from the tuning fork indefinitely. What will happen is the first set of molecules is going to collide with their closest neighbors, and then it's going to bounce back towards the tuning fork. The closest neighbors will continue moving to the right, then they will collide with another set of molecules. They will bounce back towards the tuning fork. And so we have this motion of back and forth of the particles of the medium, in this case, the air. And so the combined motion of the molecules in one direction causes them to compress into regions with higher density. So we call these regions compressions. And between those sets of compressions, we have regions where we have gas with much less density, and those regions are called rarefactions. So we have alternations of compressions and rarefactions. And that is how the sound waves propagate in air and in liquids and in solids.